All right, so now what is the linear regression equation? Well, you have to go back for that to look at the outputs right here. And they're actual pictures, or I mean, they're not, they're in there, but they're in there written out in words rather than written out in X's and Y's like you're used to from an algebra class. So the equation is right here. I mean, we already said that female literacy rate, or excuse me, yeah, female literacy rate was our X, right? You can see it on both the scatter plot and the residual plot that the female literacy rate is the X, and the Y is fertility rate. So this is saying Y hat equals 6.8 minus 0.04866 times X, right? It just doesn't come right out and say it in the exact same way. And it says it right here in Minitab as well, right? It's writing out the X in words and the Y hat right there in words. And this is reversed because statistics usually goes backwards from what we're used to from algebra class. So let me go write that up. Okay, so I've written it up here. And the more statisticky way to write it is actually on the left. This one over here. And that's actually the way they have it in the computer outputs. When you look at the computer outputs, it was saying 6.8 minus 0.0487. So it kind of went backwards from what we're used to seeing in algebra class. Algebra class always puts slope first. But as long as you remember that the slope is always the one that's multiplied by the x, then you're fine. Right? So if you look back up at the outputs, the slope is the one that's multiplied by that x, and that x is written out in words as female literacy rate. That's x. So as long as you remember that, you're fine. But of course, now we have to interpret that slope. Now for me, I know the slope is 0.0487, but I think it's honestly easier to think of that as 0.0487 over 1, which you can think of as, let's think, the y units over the x units. It's rise over run, right? Everybody learns that in algebra class. Well, the rise was our y, and our y was the, let me scroll back real quick so you can see. The y was fertility rate. So this was children per woman. Children, if I could spell, per woman. And the x was the percent that are literate. Percent literate in your country. Percent of women that are literate. Okay? So if you kind of write that out for yourself, it will very, very, very much help when you go to interpret. Sorry, I have to scroll back down. Sorry. So if I use that, that'll help me interpret it, because now I can see that I have this fraction. And what I want to say is, as X, which is the percent of women that are literate, goes up by 1 in a country, then we would expect that fertility rate to decrease by about 0.0487 children per woman. There's actually a history of this. You can actually track this, and it has been tracked by several people, that it indeed does affect your fertility rate in your country if you have a female population that's more educated. So now we want to look at what is the y-intercept and what does it mean in this situation. So the y-intercept is a point. Now remember from algebra that points actually have 2 coordinates. That's a mistake a lot of students make, is they'll just say 6.8. But the problem is, 1, that's not actually correct, and 2, it doesn't actually help you with the interpretation. It helps if you think of it as a point. It's 0, 6.8. 0 being x, which is the percentage of women that are literate, and 6.8 being y, which is the children per woman. So if you use those same units that we learned in, or that we noticed for up here in the slope, and use them again down here in this, it kind of makes sense. Now, I have a couple pieces on this. Sometimes I actually have you interpret, and sometimes I have you explain why it doesn't make sense. So in this case, we'll kind of do both. So just pay attention to what the question's asking, because this doesn't make any sense. And I guess we can just say it right now, because it makes no sense for a country to have a female literacy rate of 0. That would mean no women in the entire country can read and write, not a single one, which doesn't really make a lot of sense. There. So I'll explain both ways this time, but again, sometimes I'll just say, explain why this doesn't make any sense. So the um, well, let me do the interpretation first. A country with a female literacy rate of 0%, i.e., no women can read or write in the entire country, um, should expect a fertility rate of about 6.8 children per woman. Now, does this make sense? No, right? This does not make sense. So the Y-intercept does not make sense because it would be impossible to have a country where no women could read nor write. The Taliban actually tried in Afghanistan to make it so that no women could read or write. And even then, women were reading and writing on the side, kind of hiding it. There's actually been books written about that if you're interested. So, now, is this saying something larger about how if we have a country with low literacy rates, we'll have high fertility? Sure, but it's not really possible to have a country where no females can read or write. All right, the US has a female literacy rate of 99%. What would the model predict is the US fertility rate? Well, that is math teacher talk. I'm basically telling you that X is 99, and then I'm asking you for Y, right? So X is 99 is right here. The US has a female literacy rate of 99. Well, this won't be too difficult because all we have to do is take 99 and substitute it into the equation that we were given and solve it. So we're going to take negative 0.0487 times 99 plus 6.8. Now for the record, I'm using 99 because if you look at the table, even though this is a percentage, if you go look at the table, oh, sorry, I have to scroll back up. You can see that we're using numbers. So like 98%, 66%. So we're using whole numbers, if you will, with decimal components. So we're not moving the decimal over for each one of these. So I won't move the decimal either for my data set. You can also see it over here in the scatter plot, 10, 20, 30, 40, as opposed to 0.10, 0.20, 0.30. So I'm keeping consistent with the table and the scatter plot when I use 99 instead of 0.99. I'll make a little note of that real quick. In fact, that's actually one of the reasons that I give you the data table just to begin with, just so you can have a sense of how the numbers are going to work. And so since we were using whole numbers, we will use whole numbers for this problem. And let me show you this. So it's negative, which is down here, not the subtraction symbol, but negative 0.0487 times 99 plus 6.8. And then I just rounded. Okay, so now the US's actual fertility rate was 2.1 children per woman. So we're going to find the residual. Well, residual is the observed Y minus the predicted Y hat. So we actually observed in real life 2.1 children per woman. So we're going to take 2.1 children per woman and we're going to subtract away our 1.98. So that's what we do. Right? It's the Y real life minus the Y hat. That's actually why we call the line Y hat, is because it's not actually the actual values. It's an approximation, i.e. an average sort of all the Y values in conjunction with their X values. So it's not exactly the same thing. So 2.1 minus 1.98. Now technically this has the same unit as our data set. So this should be children per woman as the Y value, sorry, in our data set. Right, so these are both children per woman, so children per woman. Then the question is, what does this tell us about our estimate? What does this tell us about our data set? Well, the US was doing or had a little bit more fertility than we would expect for a country with our female literacy rate. I've actually decided I'm going to change what this question asks. So I'm going to say, just interpret this value in the context of the situation. And the interpretation would be that the US had a slightly higher fertility rate than we would expect for a country with our female literacy rate. In other words, our estimate was a little bit under, so we slightly underestimated. But the underestimate thing is not as important as knowing how to interpret it, right? So we had a slightly higher fertility rate than we would have expected. All right, Mali had a birth rate of 6.5 children per woman in 2007. What does the model predict would be Mali's female literacy rate? All right, so this is a little bit more algebra heavy. So we would say y equals 6.5. X is what we're looking for. So we'll take 6.5 and set it equal to the equation. We subtract 6.8 from both sides, but 6.5 take away 6.8 is negative 0.3. So then you have negative 0.3 equal to negative 0.0487x. We divide both sides by negative 0.0487. So if I take 6.5, take away 6.8, I'll get negative 0.3. Then I divide that by negative 0.0487. Enter. And I'll get 6.16. So that's where that comes from. So 6.16% of women can read and write in Mali. Let me get that in there. And there you have it. We have our percentage for X. All right, I hope that was super helpful for reviewing all the concepts that we've learned about in Chapter 4.